In this video, we'll be building the data access layer for the Habit Tracker API using Entity Framework Core, and I will share some of the practices I've used over the years with this specific ORM. Hi friends, my name is Vasily Olenik, and this is the Habit Tracker Minimal API course series where we are building a REST API backend for Habit Tracker mobile application using industry's best practices. So, the previous videos were all about us getting familiar with the minimal API programming model and all the features that it has brought with it. And starting this video, we are going to really be building the Habit Tracker API. Since writing all the code base upfront on the video would take us a lot for the data access layer, I decided to write it in the background, and then in this video we are just going to walk through everything that we have over here and everything that we need. I'll link all the source code to the GitHub repository for this specific video. Okay, so what has changed from the previous video? First of all, in the program.cs we no longer have all the API methods and all those Swagger declarations over here. So I've removed basically everything related to Swagger from the previous video, except the basic Swagger gen, the Swagger examples from assembly, and yeah, the Swagger UI. Now the next part is the contracts. Over here I've renamed the models to not have that specific DTO, data transfer object suffix. And over here we are just basically day information, habit, and habit settings. It would be easier to use these models if we will expose this specific folder as a NuGet package for future. Next, we have the validators, where we have this habit validator over here. It's the basic validator for the model from the contracts. Next, what we have is basically nothing else changed. We still have the habit service that was previously where we add, get habits, update the habits, remove, etc. Have all the operations for these datasets. So to get started with the data layer that we have over here, we will need to first install 3 packages: Entity Framework Core, Design, and SQL Server. This one is really dependable, so you would have either SQL Server or, for example, Postgre based on the provider of the database that you want to use. I'm running it on SQL Server on Mac using Docker. Why is that? It's because in the past I've had issues running SQL Server on Mac with ARM processors. And yeah, I wanted to show you that it's really possible, so I'm running it in Docker. So it's the Azure SQLedge container. Over here, I'll leave the command either on the screen or down in the bottom in the comments for you to be able to run the same image. And I'm connecting to the database using Azure Data Studio. So here is the habits database that I have generated over here. Now, since you've installed the following NuGet packages, we will need as well the CLI tools to build the migrations, which is basically you can install those by running .NET tool install global and I believe it's like this. And yeah, as you can see, .NET tool is .NET Entity Framework is already installed. If you want to update, if you have it, for example, on version 6, I have it running on version 7. If you want to update, it's basically .NET tool update global.NET EF. So it will update your tool. So yeah, tool.NET EF was reinstalled with the latest stable version 7.04 in our case. So you're gonna need the CLI tool in order to run the migrations. Now, since we've installed the Entity Framework Core NuGet packages and we've installed the CLI, the first thing that we'll need to have to do is create an application DB context class, which will inherit from the DB context. I'm not going to go into Entity Framework Core and all those configurations that we have over there, since it will take us a whole day just to go over the library itself. I'll link a couple of tutorials in the description, so go check those out as well if you want to have some in-depth knowledge. But basically what we are going to do is have an application DB context class, inherit from DB context. Over here we have a public constructor that would accept an application DB context options, a DB context options, and basically send those options to the base constructor. and have 3 DB sets, which will basically get translated into 3 tables. So the habits table, the habit settings table, and the days information table. And noteworthy fact is basically you can have the class that will represent the DB set or the table have a different name. So over here, as you can see, I have a habit data model, and the name of the property is habits. Basically, Entity Framework will take this one as the name of the table. For some reason, many juniors believe that it will take the habit data model, and then they try to configure just like has table name and all that stuff for this kind of property. By convention, Entity Framework will take these properties as the table name. Next, we have the data models, which are basically the representation of how we are going to store data in our database. So let's take, for example, the habits. And over here, as you can see, we have the habit data model, which would store an ID, a string name, user ID, a string for the user that has created this habit and is tracking it, settings ID, which will basically be the table where we are storing the settings associated with a certain habit. And over here we have the habit settings data model. So these two properties over here will set for us the one-to-one relationship with the habit settings data model. And over here we have an enumerable of the information data model, which will basically be all the tables, all the data about the days where we have checked our habits be stored. So if I go to habits data model, over here, habit settings data model, we have over here the ID, the habit ID for now, and habit. So these two in combination with these two will create a one-to-one relationship inside our database. Next, we have the day information data model, which will basically have a reference to our habit, and then we will have a daytime date and a checked boolean field. By convention, having this property over here without this one would have sufficed. Basically, we would have the habit data model over here and just have the habit, and Entity Framework in the background would create for us the column that we need for that specific relationship. But I still prefer being explicit about it and having this column and this property defined over here. So I've seen someone having something like this habit data model. This would create an issue because Entity Framework in the background would create over here another column called not habit ID but habit data model ID and make that column the foreign key. We don't want that. That's why we need to keep this part with this part consistent and have just this suffix ID over here. So we have the data models, and you might wonder, in the past we were using something like this. So on top of the ID we would have a data annotation called key and all that stuff, and over here, for example, for the name have a max length of, let's say, 100 or so. Basically, you might be wondering where all of this goes, so where all of this went, I'd say. So I've removed it all and moved to a data model configuration class. So for each data model that we have over here, we have a data model configuration class. So we started with the habit data model. Let's go to the habit data model configuration. Over here, we have the configuration class, which will basically inherit from entity type configuration of habit data model. And we would have this one method over here, public void configure, which would expect an entity type builder of habit data model, where we can start specifying our configurations for this data model. So for example, I might have that the property xName is here. We can have builder dot property, let's say user ID might be required, so is required. So saving this, and this will basically mark this user ID field as required. Over here you can have a wild number of different configurations. So what this gives us is basically we are splitting the data models from the configurations. Sometimes I've seen in clean architectures that this data model part would go into the domain, and then the implementation itself, the infrastructure layer, would have all these data model configurations with the entity framework and all that stuff. I prefer to have them together and just use the contracts, basically have interaction between the contracts. But that's just me and the constraints that I've worked so far. So you can use these data models as domain, and then you would either way have to have a contracts layer on top of the API. So you would have an API contracts layer, sorry, and expose the capabilities of your API through those contracts and through those interfaces. For this tutorial I decided to go this way. So we have data model, we have data model configurations, and basically what we might take a look is, for example, for the information data model, Entity Framework has a couple of quirks over here. First of all, data only type, Entity Framework by default does not know how to map it to the database. You would have no issues if you had here datetime or datetime offset, but yeah, date only, it has some issues. That's the first one. And second, Entity Framework expects a public property called ID to be defined on all the dbset models or the data models that you want to create a migration for. So in our case, we don't have that public property over here, and Entity Framework would throw an exception when it would try to create the migration, saying that it could not generate the primary key for this one. For that, I'm using the information data model configuration. So over here, first of all, let's take a look at the ID since we've touched it. I've specified that this dbset has a composite key based on the habit ID and date. We know that every habit would be completed only once during the day, so we have that calendar where we mark that it's either completed or uncompleted. Sorry, where it's either checked or unchecked. So we could use those two properties to have a composite key for our day information. And then we can see that over here I have a conversion, which is basically defined over here in the converters. You have a date only, and I've added the nullable date only converter. So the date only converter would convert our datetime to date only. So for that we have basically specified that the property date has conversion date only converter and has column type as date. So yeah, another way we could use the entity type configuration part over here. Since we took a look at all the configurations, we need to take a look at two things. First of all, how to apply those configurations, and then how to seed the data. So to apply those configurations, first of all, we'll have to go to application DB context. Over here on line 20, you can see that I'm applying configurations from type of application DB context assembly. So I'm specifying the assembly that Entity Framework needs to scan in order to apply all those configurations, and it would programmatically apply all of those. So if we add new tables over here, or small disclaimer, you might add the data model, you can add the data model, add a data model configuration, and not add the DB set to this specific list. And if you run add migrations, it will either way create those tables for you in the background. That's the way Entity Framework works, but for applying the configuration from a certain assembly, you would run the apply configurations from assembly command and specify which assemblies to scan. Next, what we want to take a look is basically how we can have data seed. So for that, I've created over here an application DB context seed class where I have a public static void method seed habits, which would be an extension method to the model builder. And over here you can specify model builder entity habit data model has data new list of data model, and just have all the data that you need seeded over here. What you can do as well is basically have this inside the data model configuration, since you are reusing the same model builder, but I would not do that and just keep them separate since the data seed is different from the configuration itself. If we add this line of code over here, Entity Framework, when creating the migration, will take a look at this seed habits method, see all the data that it needs to seed, and add appropriate code to the migration. So fast forward, I forgot to add one more thing over here. So basically inside our habit data model, we need to specify within one-to-one relationship which entity is the parent and which entity is the child. In our case, the habit data model is the parent for the habit settings. So when we delete a habit, Entity Framework needs to know what to do with the children, sorry. So over here, builder has one, I prefer to use it like this, so has one setting with one habit, has foreign key, and specify that the foreign key is the habit settings data model, and over here x.habitid, and on delete we want delete behavior cascade. And with that said, we are set in place. So with all that set in place, all we need to do right now is add a migration. To do that, we can run the .NET EF migrations add initial, specify the start of project, which is basically habit tracker API, and then since I have the migrations folder under the data, I'll have to specify the output directory, which is relative to the project, and right now it's data migrations. And if I hit enter, it should automatically create the migration over here. Yes, and here it is. So basically the initial.cs, over here we have the habits, the days information, the habit settings, and we have the down method. Basically what I mean by that is when we run the first time migration, when we apply the migration, Entity Framework will run all the code that's inside this up method. When we try to go back in time to a previous migration, Entity Framework will run the code base from the down method, which is basically over here. Just remove to a clean database is dropping the tables, days information, habit settings, and habits. And in order to apply the migration to our database, we need to run the .NET EF database update, and yeah, specify the habit tracker API project. It will automatically take everything that's from the up method and create the database. So as you can see, it ran the SQL, and right now if I open the database, we have the habits table, habits database with the tables, EF migration history. If I select the top 1000, it's basically initial, the habits themselves. We have .NET Learning with the empty user ID. And for example, let's go with the days information. No data is over here for those specific habits. So I'm going to close all this. And with that, we have our first migration applied to the database. Now, what we can do as well is a small adjustment. In multi-tenancy applications, we can have sometimes filters based on tenant ID. So basically every table, every useful table, you should be pragmatic about it, can have a tenant ID column there. So basically, for example, in our habit data model, we can treat the user ID as the tenant. So basically every user should have his own respective list of habits and not access other users' data. So if we want to query and always return the user's respective data, we can either pass in the user ID to the to the query, or we can apply something called like query filter, which is basically for an entity of type habit data model, we can specify has query filter, where the X user ID should be equal to something, yes? And usually this something is either retrieved from the token or from some kind of header. In our case, I can go ahead and use iToken service, which would return to me the user ID from the token itself. Right now it's a dummy service, which basically randomly returns it either a guide empty or a new guide for demo purpose only. So if I try to inject this service over here, it's just straightforward. You could have private read-only iToken service and then specify variable name. I'm going to import the missing file references, initialize the field from constructor, and then take the token service and add it over here and get user ID. So basically for the entity type of habit data model, we would always filter out the ones from the token. And since we don't currently have any endpoints, I will add one over here to the habit group and basically debug this application. Now, if I bring the browser over here, just hit it out, execute. So basically an empty response. Let's try executing it a couple of times. As you can see, I have that not learning over here return. So it's basically, since the token service randomly giving us the guide empty, it would return us randomly this list. So you can filter data out based on tokens, headers, etc, etc. Now I'm going to collapse this one, stop the API, and just remove this one method from here. Maybe for you, yeah, this is the connection string that I'm using to connect to a local database that's run in Docker. For me, it's an admin with the password 1, encryption equals false, and the database is habits. And this is the address of the database. Okay, so in this video we've covered the data access layer for the habit tracker API that we are going to use. So we've used entity framework, created the migration, applied the migration, set up a couple of converters, etc. These are just a couple of nuances from working with entity framework core in general. So if you are interested in more, I'll try to cover the topic in a later video or in a later series of videos, since the entity framework is a large topic to take into account. As a prerequisite to the next video, you should be familiar with Fluent validation and how that works. I have a video on my channel where I go pretty deep into how the Fluent validation works, what functionalities you have there. So I'll leave a link somewhere over here. Until the next time, have a nice one.